Hello my lovely students. Today you have to start it another part of rational numbers. Introduction part. In before class I have explained two fundamental theorem and one class I have explained the exercise questions. Okay. Today you have to start it from revising irrational numbers. Means how to prove root 2 is a irrational numbers. Okay. And root 5 is a irrational number. Root 3 is a irrational number. Like this. First one theorem. Theorem 1.2. Let P be a prime number if P divides A square, then P divides A. What it is written? Let P be a prime number. Means it is mentioned that one P is a which number? Prime number. P divides A square, then P divides A. Where A is a positive, integers. How to prove it? You take P is equal to 5. 5 is a prime number. Yes, P is equal to 5. Then 5 divides A is equal to 25. What is the condition it is given? P divides A square. P be a prime number. Then P divides A square. Then 5 divides 25 square. Means 5 divides 625. This is equal to A square. Yes, you take 5 with the P. Then P divides A square. Yes or no? Then same thing, 5 divides 25 also. Then what do you know? P divides A square, then P divides A also. Then the theorem is proved. Let P be a prime number, P divides A square, then P divides A, where A is a positive integers. Same thing, take to another one example. You take P equal to 5. Another one example, P equal to 3. Yes, then 3 divides 36. Yes, 3 divides 36. Means 3 divides 6 square. 36 means what? It is 6 into 6, 36. Then 3 divides 6 also. You take to any prime numbers, then you will be divide the squares, then it will be divided by the single number also. This theorem will be proof that parts. Then theorem 1.3. What it is? It is written root 2 is irrational. You have to prove it. Root 2 is a irrational number. This theorem is required for to this theorem. Okay, it is necessary. Now let root 2 be rational. What? Root 2 be rational. You take it root 2 be a rational number. Rational number means it is the form of P by Q, where Q is not equal to 0. Then root 2 is equal to A by B, where A and B are co-prime and B is not equal to 0. What is the meaning of co-primes? The meaning of co-prime means you have to take two numbers, the SCF is 1. Yes, the SCF is 1, then this is the co-prime numbers. Means you take it 3, 4, these two numbers. The SCF of 3 and 4 is equal to 1. Same thing 9 and 10. The SCF of 9 and 10 is equal to 1. These two are the co-prime numbers. Okay. Then this is 1. Then you do it the cross multiplication. Root 2 into b is equal to a into 1. Then squaring both sides. You take squares on both sides. Root 2b square is equal to a square. Then it is root 2 into root 2. What is the meaning of that? Root 2, here see, root 2 into root 2, this is equal to 2 into 2 root over is equal to, I have already read no, root a into root b is equal to root ab. Same thing, 2 into 2, then 4 root over is equal to 2. Yes, then root 2b square is equal to 2b square is equal to a square. This is equation 1. In this form, what do you see? 2 divides a square. Yes or no? 2 divides which square? A square. In this theorem, in theorem 1.2, p divides a square, then p divides a. Same thing, 2 divides a square means 2 divides a. Now the next, before 2 divides a square, then 2 divides a. In the theorem I have proved it. Then 2c is equal to a. What it is? You take 2c is equal to a. Another one condition you take 2c is equal to a. Where c is any constant. You take it any constant. Means you check that one. 2 divides 14. 2 divides 14 means 2 into 7. What is the value of c? c is equal to 7. Then it is divides. Yes or no? Then same thing, another one example. Any constant means you take it any constant. 2 divides 16. Then 2 into 8 is equal to 16. Yes, that's why you take c is any constant. Then same thing, squaring both sides. 2c squares is equal to a square. You take it LHS and RHS, both the sides of squares. Then 2c squares means it is what? 2c square means it is 4, 2 square 4, c square. This is 4c square is equal to, what you take? A square. In the equation 1, a square is equal to, in equation 1 what you got it? A square is equal to 2b square. Yes, in equation 1, here you see, in equation 1, a square is equal to what? 2b square. Yes, then put this value in equation 1, 2b square. Then here you divided. See how to? 4c square is equal to 2b square. Then 4c square by 2 is equal to 2b square by 2. 2 cancel, this is 2. Then 2c square is equal to b square. Same condition it is coming also. 2 divides b square. Then 2 divides b in this theorem 1.1. Then what do you know? A and b are, the common factor is 2. But you take a and b as the co-prime number. The common factor is, the SCF is what? 1. But here it will be contract. Because here it will be, in equation 1, 2 divides a square. In equation 2, 2 divides b square. Yes, this is equation 2. You take it equation 2. In equation 1, 2 divides a square. In equation 2, 2 divides b square. That's why a and b, what do you take? A and b are the co-prime number. But here a and b are the common factor is 2. Then a and b are not co-primes. Yes, that's why our assumption was wrong. What? Our assumption. What have take the assumptions? Assumption you take root 2 is the rational numbers. But here root 2 is not, because root 2 is not a rational numbers, because a and b are not a co-prime numbers. That's why root 2 is irrational. This is only for the 4 steps. The first step, you take root 2 is a rational numbers. Then rational means it is a by b form. Then b is not equal to 0 and a and b are the co-prime numbers. What is the meaning of co-prime? The SCF is 1. Then you take the squaring of both sides. Then 2 divides a square. Then 2 divides a. This is equation 1. And another thing you take it because b, how to prove it b. That's why this is 2c is equal to a. What is 2c means c is any constant. Yes or no? Then c is any constant. Squaring both sides. Same thing 2 b square c square is equal to a square. Then 2 divides also b square. Then 2 divides b. A and b is the common factor is 2. That's why this a and b are not co-prime. Then another one example. You take it same thing. Root 3 is a irrational numbers. Root 5 is a irrational numbers. Same procedures. Okay, same process you solve it out. Another one examples. 6 plus root 3 is irrational. This is very simple, you prove it out. In root 2 is irrational. That's why it is another one of the simple questions. Let 6 plus root 3 is rational. What you take? 6 plus root 3 is rational. 6 plus root 3 is equal to a by b, where a and b are co-prime. Yes, co-prime means what? The SCF is 1. Then root 3 in LHS side is equal to a by b. 6 is positive. Opposite side you move it. Then it is negative. Then root 3 is equal to the LCM is b. A minus this is 6b. What? A minus 6b divided by b. This is a rational numbers. It is a which number? A minus 6b by b. It is a rational numbers. But you have to prove it. Root 3 is irrational because in theorem 1.3 I have proved it out. Root 2 is irrational. Same thing root 3 is irrational. Since we know that root 3 is irrational. This contradiction of our factor, of the factor. So our assumption was wrong. 6 plus root 3 is irrational. Okay. Now see how to prove it. 6 plus root 3 is irrational. Same thing. Another one example. Root 3 is irrational. In the exercise question also. In exercise 1.2. First one, prove that root 5 is irrational. 2 number, prove that 3 plus 2 root 5 is irrational. Then 3 number question I, 2i and 3i, prove that the following are irrational. 1 by root 2, I number, I bit, 2i bit, 7 root 5, then 3i bit, 6 plus root 2. Okay, in the next class, I have solved this exercise problems. Anyone any doubt? Will ask me in the comment box. Bye bye and take care. Thank you all of you.